Coordinate geometry, the equation of a circle. Equation of a circle. A circle is the locus of a point at a fixed distance from a fixed point. Given a circle centre C at AB, with radius r, we can find its equation by considering a general point A at xy on the circumference. Now we have that CA is equal to r. We can use the formula for finding the distance between 2 points, which is the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. In this case, x1 is a and y1 is b, x2 is x and y2 is y. So this gives us the square root of x minus a all squared plus y minus b all squared is equal to r. And if we square both sides, we get x minus a all squared plus y minus b all squared is equal to r squared. Now this is the general equation of a circle, centre AB and radius r. This expands to x squared minus 2ax plus a squared plus y squared minus 2by plus b squared equals r squared. Or x squared plus y squared minus 2ax minus 2by equals r squared minus a squared minus b squared. Now we can notice a few things. The equation is a quadratic in x squared and in y squared. The coefficients of x squared and y squared are equal. There is no xy term. If the circle has its centre at the origin, then the equation is x squared plus y squared equals r squared. If the equation is x squared plus y squared plus gx plus hy equals k, then the centre is at minus g over 2 minus h over 2. Completing the square. To find the centre and radius of a circle, we can use completing the square. Suppose we have the equation x squared plus y squared plus 4x minus 6y equals 3. To complete the square, the first thing we do is we have to rearrange it. We put the x terms together, so we have x squared plus 4x and we leave a gap. Then we put the y terms together, so we have y squared minus 6y and we leave a gap. And we make sure we have all the number terms on the right-hand side. Now, we look at the number in front of the x term. That's 4. We halve it, we square it, and we add it to both sides of the equation. Then we look at the number in front of the y term. That's minus 6. We halve it, that's minus 3. We square it, and we add it to both sides of the equation. Now we can factorise the left-hand side in 2 pairs. So x squared plus 4x plus 2 squared becomes x plus 2 squared. And y squared minus 6y plus minus 3 squared factorises as y minus 3 squared. And the right-hand side simplifies to 16. Now that gives us x plus 2 squared plus y minus 3 squared equals 4 squared, which is the standard form for a circle, and we can read off the centre of the circle is at minus 2, 3, and the radius is 4. Let's have a look at some examples. Example 1. Find the equation of the circle centre 2 minus 3 passing through the point 1, 7. To solve this, the radius is the distance between 2 minus 3 and 1, 7. So, r squared is equal to 1 minus 2 squared plus 7 take away minus 3 all squared. In other words, r squared is equal to 1 plus 100, or r squared is equal to 101. Then the equation of the circle is x minus a all squared plus y minus b all squared equals r squared. and in this case the equation is x minus 2 all squared plus y plus 3 all squared equals 101. Now we can draw this in a diagram with the centre at 2 minus 3 and the circle passing through the point 1, 7. In example 2, we're asked, find the radius of the circle that has centre at the origin and has the line y equals 2x plus 5 as a tangent. Well, to solve this, we can find the intersection of the line and the circle by solving the simultaneous equations. So, substituting y into the equation of the circle, we have x squared plus 2x plus 5 all squared equals r squared. And if we expand the brackets, that gives us x squared plus 4x squared plus 20x plus 25 equals r squared. And that simplifies to 5x squared plus 20x plus 25 minus r squared equals 0. Now, if the line is a tangent, there can only be one root to this. So the determinant b squared minus 4ac is equal to 0. Now the determinant is 20 squared minus 4 times 5 times 25 minus r squared. Now we can divide all the way through by 20, and that gives us 20 minus 25 minus r squared is equal to 0, or r squared equals 5, which tells us the radius is equal to the square root of 5. We can draw this in a diagram. If we consider the equation y equals 2x plus 5, if x is 0, then y is 5. If y is 0, then 2x plus 5 is 0, so x is equal to minus 2.5. If we plot those 2 points on the graph, then we can join them with a straight line. If we draw the circle, centre the origin, just touching the line, we see it touches the line at the point minus 2, 1. From Pythagoras' theorem, we can see that the radius squared is 1 squared plus minus 2 all squared. And so that's 1 plus 4, which is 5. And so the radius is equal to the square root of 5. In example 3, part 1, we have to find where the line y equals 2x plus 3 intersects with the circle x squared plus y squared plus 4x plus 8y plus 2 equals 0. To do this, substitute y from the first equation into the second equation. That gives us x squared plus 2x plus 3 all squared plus 4x plus 8 into 2x plus 3 plus 2 equals 0. If we expand the brackets, this gives us x squared plus 4x squared plus 12x plus 9 plus 4x plus 16x plus 24 plus 2 equals 0, which simplifies down to 5x squared plus 32x plus 35 equals 0. Now, we want to factorise this. So we want two numbers, p and q, that add to make 32 and multiply to make 5 times 35. In other words, multiply to make 175. Now those two numbers are 25 and 7. So we can divide the middle term 32x into 25x plus 7x. Now if we look at the equation 5x squared plus 25x plus 7x plus 35 equals 0, we can factorise it pairwise. The first two terms have 5x in common, so that's 5x into x plus 5, and the second two terms have 7 in common, so that's plus 7 into x plus 5 equals 0. Now the two brackets are the same, and so we can again factorise and have 5x plus 7 into x plus 5 equals 0. Now if two things multiply to make 0, then one of them is 0. So 5x plus 7 equals 0, or x plus 5 equals 0, which means x is equal to minus 1.4 or x is equal to minus 5. Now y is equal to 2x plus 3, so if x is equal to minus 1.4, then y is equal to minus 2.8 plus 3, which means y is 0.2. If x is minus 5, then y is minus 10 plus 3, so y is minus 7. Now that means the intersection points are minus 5, minus 7, and minus 1.4, 0.2. Now in part 2 it asks, draw the graph of x squared plus y squared plus 4x plus 8y equals 2. To do this, we need to rearrange the equation by putting the x terms together, the y terms together, and the number terms over on the right-hand side. Now that means we can then complete the square. We put the x terms together followed by a gap, the y terms together followed by a gap, and then we take the number in front of the x term, halve it, that's 2, square it, and add it to both sides. Then we take the number in front of the y term. Now that's 8. We halve it, that's 4, square it, and add it to both sides. Now that means on the left-hand side we can take the terms 3 at a time and factorise them. So x squared plus 4x plus 4 factorises as x plus 2 all squared, and y squared plus 8x plus 16 factorises as y plus 4 squared. The right-hand side simplifies to 18. Now that's the standard equation of a circle. So the circle has centre minus 2 minus 4 and radius the square root of 18, which can be written as 3 root 2. Now to draw the graph, we need some graph paper. We draw a circle, centre minus 2 minus 4, and we draw the radius 3 root 2. Now that's actually a diagonal which is 3 squares across and 3 squares up. So in fact it goes through the point minus 5 minus 1. Now in part 3 we have to draw the graph of y equals 2x plus 3. To do this we complete a table for y equals 2x plus 3. Now I've chosen values for x of minus 6, minus 4, minus 2, and I need to work out the values of y. Well, y is 2x plus 3, so twice minus 6 is minus 12, plus 3 is minus 9. Twice minus 4 is minus 8, add on 3, that's a minus 5. And twice minus 2 is minus 4, add on 3, that's minus 1. So we can plot these points and join with the straight line. We see that the circle and line intersect at minus 5, minus 7 and minus 1.4, 0.2, which is the same as we had before in part 1. In geometry, we have a theorem that says the angle in a semicircle is a right angle. Now we're going to prove that not using geometry but using algebra. So this is our example 4. A circle has centre at the origin and radius 1. The points A, minus 1, 0, and B, 1, 0, lie at the ends of a diameter. C, xy, is another point on the circumference of the circle. We want to prove that the angle ACB is a right angle. Now we need a diagram and we need to mark in the points. The equation of the circle is x squared plus y squared equals 1. That means x squared minus 1 is equal to minus y squared. Now we can find the gradient of AC. The gradient is y2 minus y1 over x2 minus x1. So in this case, the gradient of AC is y minus 0 over x take away minus 1. In other words, y over x plus 1. And the gradient of BC is y minus 0 over x minus 1, which is y over x minus 1. Now if we multiply these two gradients, the gradient of AC times the gradient of BC is y over x plus 1 times y over x minus 1. Now that's y squared over x squared minus 1. But we've just shown that x squared minus 1 is minus y squared. So the product is y squared over minus y squared, which is equal to minus 1. Now if two gradients multiply to make minus 1, they're perpendicular. So AC is perpendicular to BC, and the angle ACB is equal to 90 degrees. It's a right angle.